my name is Kshitij Kapoor. This is the Coding Tree, and today we're going to be talking about binary and machine code. Today's also our first ever programming lesson, yay! We won't actually be coding though. I know, but don't click off the video just yet. We're going to be starting soon, just wait till the next video. Today's video is actually a really important lesson, which is vital so you can actually learn how everything in programming works and how a computer reads a programmer's code. The actual process of this can be very confusing and elaborate as seen by this GIF here, but don't worry, we're not going to get into all of that today, but by the end of this, you're going to have a great general understanding of how programming works and its total functions. Let's get straight into the first topic of today's video, binary. I'm sure everybody here knows what binary is, but today we're going to get into the nitty-gritty of binary, specifically how it's read and its function in programming. To understand binary, however, we first have to understand our own number system. The number system that we use in our day-to-day lives, and I'm sure the number system that you're most familiar with, is the base 10 system, otherwise known as decimal, a word that stems from the Latin word decimus, meaning tenth. This also means that it consists of 10 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the number system that we're definitely most familiar with, and that's what we use. But there's no actual reason for us to use this system. Why can't there be a system where there are only 8 digits? On the other hand, why can't there be a system where there are 11 digits with an additional character or symbol to represent the digit 10? Well, scientists generally agree that the reason that we use the base 10 system over any other system is because of the way humans evolved and started learning math. When we started, we just used our fingers, and since we have 10 fingers, we naturally use the 10-digit system. Computers, however, aren't humans. They use the base 2 system, otherwise known as binary. Here, you can see an example of a number written in base 10 compared to a number written in base 2. Let's look at the base 10 number first, so that we can understand the base 2 number. How do you get to the number 155? You could argue that you just count up, but that's not really true, is it? You don't count up on every single digit when you go up 1, you only increase the ones digit. Or if you're at a number like 199, you completely change the number and go 200. Why is that? Well, that's because of how numbers are represented in base 10. The number 155 is essentially just the number 1, the last digit, multiplied by 100, the 5, the second digit, multiplied by 10, and 5, the first digit, multiplied by 1. When you add all of those up, you get 155. Well, how is that? Why is it that we use the numbers 1, 10, and 100? Well, because they're all powers of 10. 1 is 10 to the power of 0, 10 is 10 to the power of 1, and 100 is 10 to the power of 2. In these number systems, we always use the multipliers as the powers of the base. Next, let's take that same concept and apply it to binary. Recall that binary is base 2, which implies two things. 1, we will always be using only 2 digits, 0 and 1, and 2, we will always be using powers of 2 as our multipliers. So the first digit will be 2 to the power of 0, the second 2 to the power of 1, and the third 2 to the power of 2. So let's get back to the number 155, because it'll be represented in binary as this number. Why? Well, let's break it down the same way we did base 10. We can think of the multipliers in places as powers of 2. Thus, the number to the very left is 2 to the power of 7, or 128. The number to the very right is 2 to the power of 0, or 1. And remember, since there are only 2 digits, there are only 2 possibilities. Either that base is being multiplied or it isn't. So for now, we can just gray out all of the zeros and only focus on the ones. Thus, we can see that 2 to the power of 7 is a 1, which means that it is being multiplied by 128. 2 to the power of 4 is 16, which is being multiplied. So we add 128 and 16. 2 to the power of 3 is a 1, which means that it is being multiplied, which means we add 128 plus 16 plus 8, and 2 to the power of 0 is 1, which means that we add it to the sum total after multiplying it, which eventually gives us 155. Okay, now that you did a problem with me, pause the video and do this problem. Convert this binary number to a base 10 number. Is this what you got? 123? If so, great. Okay, one last practice problem. This time something that I didn't really go over, but with intuition you can figure this out. I know you can. So the number is right here. Convert this number into binary. Did you get this? If so, great. You're beginning to learn how to use binary. Now that you have a basic understanding of binary, we can go over why it has such a big impact in computers. And that's essentially because of the fact that it only consists of 2 digits. And since computers are essentially working on ons and offs, the numbers 0 and 1 are crucial. 0 representing off and 1 representing on. And thus we arrive at the most important part of today's lesson. When we start coding in the next lesson, you will be using an IDE, or Integrated Developer Environment. This is crucial because it houses a very important process in converting your code into code that machines can read, otherwise known as machine code, which is essentially just binary. That element is the compiler, because it is responsible for turning your code into machine code. Understanding this is a key part in understanding a computer's inner workings, and thus a key part in beginning your computer science journey. That's all for today, folks. I hope you enjoyed, and I hope you learned something. If you did, make sure to drop a like, as it would help me out a lot. And make sure that if you want to see more content like this, and if you want to continue your computer science journey, you hit the subscribe button right here. If you want to watch the next episode or the next lesson, click here to go to that.